When we look at the various electrical potentials given for various half reactions, it's important to remember that all of those values that are listed have to be measured against some other cell. Now, the standard cell that is usually used is the hydrogen cell, and that is found right here. And we see that this has an electrical potential of 0.00 volts. In this question here, we're being asked, well, what if we change the reference half cell to something that isn't hydrogen? Let's instead use the mercury 2 half cell and use that as the cell that we're going to measure everything against. So if we take a look at where mercury is, we see mercury is found right here on our list of tables. So what we're saying is that instead of mercury having this value of positive 0.85, it's not going to be that anymore. Instead, we're going to make that our reference cell, and it's going to have an electrical potential of 0.00 volts. So what that does is that changes all of these other values up here because they're no longer being measured against the hydrogen cell. Instead, they're being measured against the mercury cell. So our first question is what would be the reduction potential of the standard chlorine half cell? So now this value is not going to be 1.36. We know it's going to change because we're using a different cell to measure against. So what is this difference then between the mercury 2 cell and the chlorine half reaction? Well, if we take positive 1.36 volts and we subtract positive 0.85 volts, we get a value of positive 0.51 volts. So that is the new electrical potential for that half reaction. It is positive 0.51 volts. Now for part B, we're asked what is the reduction potential for the standard nickel half cell? And the standard nickel half cell is right down here. So again, we're trying to find this difference right here. So to figure out that difference, I know that I have to go from the mercury 2 cell down to the hydrogen. That is a difference of 0.84 volts. And then I've got to drop even further. I've got to go from 0 down to negative 0.26. So that difference is another 0.26 volts. And if we add these together, we get a difference, a total difference of 1.11 volts. And this is going to be negative because it's measured from the half cell and it's going down. So we're going down in this direction, so it is a negative cell potential. So for part C, we're then asked, well, what is the net cell potential for the standard chlorine nickel half cell? For this, we just have to use that formula, E cell equals E cathode minus E anode. And if we find out what we'll be using right there, here is what's at the cathode, here is what's going to be at the anode, and if I take our new values of positive 0.51 volts and I subtract from that negative 1.11 volts, we get an answer of positive 1.62 volts. And what's interesting is if you were to calculate the cell potential for the chlorine nickel cell using just the regular hydrogen half cell, you should find that that value of positive 1.62 volts using the values that are found in your table are again that 1.62 volts. It doesn't matter which standard cell we're measuring against, that difference or the net cell potential will be the same.